is Zulhadi Ashraf Rezeki from DET 1F. My register number is 04DET25F1151.
Hi, Assalamualaikum. My name is Muhammad Izan Shafiq Zohiri bin Abdul Rahman. My registration number is 04DET25F10 and 35.
Hello, my name is Muhammad Izzuddin bin Muhammad Mazlan. My matrix number is DET 25F1157.
Today I will to present about safety precaution before using an oscilloscope. Number 1 is pet equipment carefully. We should check the cables for any physical damage such as frayed wires or broken connectors. Number 2, use the correct probe type. We must select probes that match the voltage and signal type of the circuit. Using an underrated probe can result in equipment damage or personal injury. Number 3, is paper grounding. We should always connect the probe's ground clip to the circuit ground first. This helps prevent ground loops and protects both user and equipment. Number 4, avoid high voltage circuits without precaution. For high voltage circuits, use differential probes or isolation techniques. Never connect a standard oscilloscope directly to high voltage sources. Number 5, set voltage and time per division correctly before testing. We should adjust the vertical volt per division or horizontal time per division settings beforehand to prevent waveform distortion or overloading the screen. That's all from me. Thank you.
This is an analog oscilloscope. An oscilloscope is an instrument that allows us to see electrical signals in the form of waveform. Unlike a multimeter, which only show number, the oscilloscope show how voltage changes over time, which make it very useful for analyzing circuit. On this oscilloscope, the first control we can see are the intensity, focus, and trace rotation. The intensity adjusts the brightness of the waveform. The focus makes the trace sharper, and the trace rotation is used if the horizontal line looks straightly tighter. Next is the vertical section, the main knob here, which the volt per division, which control how much voltage each division on the screen represent. There is also a position knob that move the waveform up or down, and a coupling switch which can be set to AC, DC or ground depending on how we want to observe the signal. This oscilloscope has two channels, channel 1 and channel 2, which means it can display two different signals at the same time. On the right side is the horizontal section. The main control here is the time per division, which set the time scale and determine how fast the signal is displayed on the screen. There is also a horizontal knob, a horizontal position knob to shift the waveform left or right. Below that, we have the trigger section. The trigger is important to keep waveform stable. If there is no trigger, the waveform will keep moving across the screen. The trigger level knob allows us to choose at what voltage the oscilloscope start drawing the signal. Finally, at the bottom, we have the input connector where we attach the probes to measure signal from a circuit. By understanding their control, we can use the oscilloscope correctly and make sure the waveform we see is clear and accurate. That's all from me. Thank you for your listening.
Hello, today I want to present the technique of using an analog oscilloscope for calibration. Step-by-step calibration produced. Number 1. Preparation. Reviews the oscilloscope manual for model-specific instruction. Ensure the device is clean, undamaged and connected to a stable power. Number 2. Warm-up. Power on the oscilloscope and allow 15 to 30 minutes for thermal stabilization, especially for CRT-based model. Number 3. Set control to default, center of knobs and disengage push button. Set volt per division to 1 volt and time per division to a moderate value. Number 4. Kena potong. Pandai. Connect calibration. Number 4. Connect calibration signal. Use the oscilloscope's built-in calibration output, typically a 1 kHz square, wave at 1 volt peak to peak. Connect a probe to the calibration terminal and ensure proper compensation. Number 5. Verify vertical accuracy. Observe the waveform. Each vertical division should represent 1 volt. Adjust vertical gain if necessary to match the expected amplitude. Number 6. Check horizontal accuracy. Confirm the waveform's frequency using the time per division setting. Use a frequency counter or signal generator for compression. Number 7. Trigger and sweep calibration. Ensure stable triggering of waveforms. Adjust sweep linearity and trigger level to maintain consistent display. Number 8. Probe compensation. Use the square wave to adjust probes until waveform edges are sharp and flat. Number 9. Document result. Record calibration values and deviation. Environmental condition, temperature, humidity for traceability. Number 10. Repeat periodically. Perform calibration at regular intervals.